Hey, today we're going to talk about circles. Mainly we're going to talk about area of circles. So here we go. The nice thing is we have a formula. Y'all know I love me a formula because I can just take those numbers, plug it in, and I let the calculator do the work. So the formula for the area of a circle is pi r squared. So we see this down here, okay? And as you know, a circle has a radius. From this center point right here, the center of the circle, to the edge at any point on the circle is called the radius. The radius could go from here to here, it could go from here to here. It's just the center to the edge at any point. So there's a bazillion lines that can be called the radius because the distance and the measurement of the radius is always the same. So let's pretend our radius in this situation is 5. So if we wanted to find the area or the space inside that turquoise circle, you would take 5 and you just plug it into our formula. So we're going to take 5 and we're going to put it right there in place of our r in the formula. So it would look like this. Area equals pi times 5 squared. And then just be careful because remember your order of operations tells you that you need to do the exponent first. So you would go ahead and again, you can just use your calculator. I use my phone. My iPhone has a great calculator. When you turn it sideways, you have all of the functions that you need for geometry. So you can push 5 and then you can go ahead and push that square root button. A lot of times I do it in my head because then I know that I did that operation first. So from here, 5 squared is 25. So we have the answer is pi times 25. Now we basically have two choices from this point. Sometimes they want you to leave the answer in what's called in terms of pi. What that means is they don't want you to round pi. Pi is a ratio, which is a decimal that goes on and on and on. So sometimes they want you to leave the answer as 25 pi. That's it. You put the number before the pi symbol. It's just the proper way to write it. Or, again, you can take your calculator, and do you see this? Look at that fancy button. I have my pi button. So I can hit, I already have 25 here, I can hit times pi. There's pi, that decimal that goes on forever, and I hit equals, and there's my answer. Now, again, it's a decimal that goes on and on, so I'm just going to go ahead and round. So my answer is 25 pi, or I can put 78.5. It looks like I can round. Both of those are equivalent. You'll have to look at how they want you to represent your answer. Do they want you to round the decimal, or do they want you to leave your answer in terms of pi, which would make it more accurate? Okay, so that's how you'd find the area of a circle. It's probably just refreshing your memory at this point, but what I really want to help you do today is find the area of a sector. A sector is a piece of a circle. It's like a piece of a pie. So here's what we're going to do. In order to find the area or the space of that yellow portion right there, first you have to find the area of the whole thing. And then we can know how much that little piece is based on how much of the circle it's taking up. It's kind of like if you know that let's pretend that Miss Davis weighs 100 pounds. Woohoo! But I want to know, how much does my arm weigh? I don't know. But if I know that my arm is, let's say, 10% of my total body weight, and I weigh 100 pounds, my arm weighs 10 pounds. So that's kind of the logic that we're doing with the circle. You have to know how much the whole thing is first, then we can find the portion. Okay, so here we go. Let's pretend this circle here, now we're looking at that yellow piece. We're going to pretend that that has a radius of 4. Okay, and you also have to have, so not only do you have to have the radius, you also have to have the degree of the angle for that sector. So we're going to pretend that this is, we're going to go with 30 degrees. 30 degrees. Boop. Okay, so like I said, first things first, you got to find the area of the whole circle. So we're going to go back to our formula down there, right? So area equals pi r squared. So in this case, I'm just taking my info, plugging it in. So area equals pi times r squared. In this case, our r is 4, so that's why I'm putting 4 in place of r. And then we're going to square it. So 4 squared is 16. So I end up with pi times 16. Now, because we're finding the area of the sector, I'm actually going to go ahead and get my decimal answer. So I'm going to go ahead and do 16 times, and again, I got my little pi button, and then I hit equals. And so the area of the whole circle, in this case, is 50 I'm going to round up to 3, 50.3. So 50.3 is the area of this whole thing. But I only want the yellow guy. The yellow guy has a degree of 30 degrees. And the whole circle has a degree of 360 degrees. So what we can do is, we have two options. I'm going to show you both. But I think it's easiest to just set up a proportion. So here we go. 50, change colors. I'm going with red now. 50.3 is the area for all 360 degrees. So it's kind of like this is my fraction that's representing the whole thing, the area of the whole thing, and then the degree of the whole circle. But we need it to be proportionate, and I am trying to find the area, so I need this area for only 30 degrees. So see how you match up the degrees on the bottom and the areas on the top, and then make sure you have, the entire area with the entire degree goes with the portion of the area with the portion of the degree. And then from here, hopefully you remember how to solve a proportion. You cross multiply. Some of you have heard the butterfly method. You multiply diagonally. So you would do this times this. So 50.3, I just still have it on my calculator. I'm going to multiply that times 30, and I get 1,507. So 1507 equals, but remember, you also have to multiply this way, equals 360 times the area of that portion. But we're trying to get A by itself. So then we would divide by 360. So I'm just going to keep that answer and divide by 360. And I'm getting an area of 4.18. So I'm going to round to 4.2. So if the whole circle had an area of 50, the little yellow portion would have an area of 4. And that does sound about right. Now, here's the other option. The other option is basically to figure out what percent is 30 degrees of 360. Okay, so you could, again, you could do that on your calculator. You have to always still find the area of the whole circle first. So I would do 30 divided by 360, and I'm getting that. Remember, a decimal is the same as a percent, but you got to shift that decimal over. So the yellow portion is approximately 8% of the entire area. So you could take this percent and multiply it by the entire area, which we got was 50.3. And I'm getting 4.19 again, which rounds to 4.2. So again, I'm just showing you two separate ways to do it. One option I showed you in red was to create a proportion and set up two fractions, the whole area with the whole degree versus the portion of the area versus the portion of that degree central angle. The other option is to do a percent. So you would do 30 divided by 360 tells you what percent of the circle you're trying to figure out, and then you multiply that times the entire area. Whatever works for you, and again, just remember, your calculator is your best friend. Now we're going to talk about circumference. Circumference is just a fancy word for the perimeter or the outside edge of the circle. So it's really just the distance all the way around a circle. So here you can see the different parts of the circle. The circumference is that red line that's going all the way around. And now I'm trying to draw a purple line. Whoop. all the way around. The radius, as you recall, is from the center to the edge, and the diameter is from edge to edge, but it must go through the center, so the distance all the way across. So if you needed to find the circumference of a circle, you need, as always, we need the radius. We have to have that information. So let's go down to this circle over here, and let's pretend our radius is 10. If our radius is 10, we can just, again, plug it into our formula. Circumference says that the circumference formula tells us that it's 2 times pi times the radius. So 2 times pi times our radius in this case is 10. So our circumference, we can put 2 and 10 together. If we multiply that, we get 20 pi. So again, here you have a couple options. Sometimes they will want you to leave your answer in terms of pi, and you can leave it, and the answer is just 20 pi. Or you can use your calculator, and you can literally hit 20 times your pi button and hit enter. And I'm showing a circumference of 62.8. 62, whoops, that's not the right spot. 62.8 is the distance all the way around, okay? Well, let's pretend this purple circle has the same radius, but I only want, find a better color, I only want this portion right here. I want this little tiny arc length. An arc is basically just a little piece or chunk of the circumference right there. So in order to find an arc, you have to have 2 pieces of information. You must have the radius of a circle always, in this case is 10, and you also need that central angle. In this case, we're going to say the central angle is 60. So again, 2 ways to do it. We could set up a proportion, or we can do the percentage. So I'm going to do the percentage first this time because I did the other way around last time. So what percent is 60 degrees out of 360? So 60 degrees out of 360 degrees is, I know some of you can do this in your head, this much percent, okay? So if that's the percent that I need, basically that arc is 16% of the total circumference. So I could take that and then you multiply it by the total circumference, which we already found was 62.8. And so I'm getting that that arc would end up being about 10.5. So this would be about 10.5 when the distance all the way around is 62, okay? Remember, your other option is to set up a proportion, and it would look like this. 62.8 goes with all 360 degrees, and I need a proportion of the arc over only 60 degrees. And then again, let the calculator do all the work. You would cross multiply. You would cross multiply 62.8 times 60 and then divide by 360. And I'm getting 10.46, which again, we rounded to 10.5. So that is how you find circumference, and that is how you find an arc length if they only want a chunk of the circumference. Okay? Good luck, guys.